So on number 1, you could go parenthesis, 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 because the a value is 1, right? The a value is 1, so you are able to put an m right here and an m right there, and then think what times what is 64, that if you add together is 16, and you should realize that it's 8 and 8, right? So you could put plus 8 and plus 8, and that is factored. But what this section really wants you to practice is recognizing when you have a perfect square term in the front and a perfect square term in the back, and then square rooting each of them. The square root of m squared is m, the square root of 64 is 8, and just plugging in the m and the 8, the m and the 8, and then determining your signs based on the signs in your original polynomial. Got that, Asad? Okay, so on this one it wasn't necessary to do that shortcut, but it's because it's pretty easy to think what times what is 64, that if you add together is 16. Now number 2, on the other hand, number 2, if I asked you to factor it and you didn't know the shortcut, you would start doing the long process of a times c and getting out a 9, and then thinking of the multiples of 9 that combine together to give you -6, and then you'd have to rewrite it as a polynomial of 4 terms so you could factor by grouping, and it gets pretty long. But if you recognize that this first term is a perfect square term and this last term is a perfect square term, you could square root both of them and you could try to plug it into your answer format. So what is the square root of 9r squared? 3r. And what's the square root of 1? 1. So you really have a 3r on both parentheses with a 1 right next to it. Now we need to determine the sign. The only way to get +1 is if this is a +1 times a +1, or if it's a -1 times a -1, right? So based on your middle sign, you probably want these guys to be negatives because your middle sign's negative. If everything were positive, then yeah, it'd be a plus and a plus. So you want it to be a -1 times a -1. Let me write that in, -1 and -1. So this is our best guess at the factored form without having to do all that work. Okay, now you can only do this if you have a perfect square term in the front and a perfect square term in the back. But you are supposed to verify it, right? Let's verify. If I go 3r times 3r, that is 9r squared. If I go 3r times -1, that's negative. I'll get -3r. And -1 times 3r, that's -3r. And -1 times -1 is +1. So we really do see that when I combine the middle terms, -3r and -3r, we do get the -6r. So this does work. So this is the correct factored form. Okay, so this is like a shortcut. So you don't have to do a times c, get a number, think of the multiples of that number that combine together to give you the middle value b. So you don't have to use factoring by grouping. Now, this doesn't work all the time. It only works when you have a perfect square number in the front and in the back, and you also need to verify that it actually does produce the middle value. Okay, so looking at number 3, and I know that you have a perfect square term here, a perfect square term there, so let's square root the first one. What's the square root of 4y squared? 2y. And how about the square root of 25? 5. So we have a 2y and a 5. Now we need to ask ourselves, if I need to get 25 at the very end, it's either going to be a +5 times a +5 or a -5 times a -5. Now since the middle term's negative, you need to have some negatives involved, so that must mean that it's a -5 times a -5. So put that -5 right there and -5 right there. And then you could either work it through, or in your head, you could try to figure out if the middle term really will be -20y. So 2y times 2y is 4y squared. Okay, that's no problem. But 2y times -5, that's -10y. And if I go -5 times 2y, that's another -10y, which combined together really does give me -20y. So I know that this is the right factored form. So I'm done. Does that make sense?
Yes.
So it's pretty simple. All you got to do is verify, though. Okay, you got to verify by checking your middle value and making sure that it actually does give you that b value right there. So let's take a look at number 4 here. Number 4. What is the answer going to be? Notice that they're all plus signs. So what's my answer going to be? 4p 3. And yeah, both of them are going to be plus. By the way, guys, all of these also could be rewritten. If you have a binomial times the same exact binomial, you could, if you wanted to, write it like this. 4p plus 3 squared. Okay, if you wanted to. But I'll accept either one of these. Now, we just need to verify that it actually does work. And I know it does because 4p times 3 is 12p, and 3 plus 4p is another 12p, and 12p plus 12p will give me the middle value, 24p. Cool? I believe number 5, it looks like it's going to work because we have a perfect square term right here. We have a perfect square term over here. When we square root it and plug it into our answer format, we're going to get what? 5b with the 4 and 5b with the 4, right? Now, I know I need a positive 16 at the end of it all, so it's either going to be positive 4 times positive 4 or negative 4 times negative 4. What do you guys say? It looks like negative 4 times negative 4. However, when you check it, you'll see that the middle value doesn't end up becoming negative 4b. Check it out. When I go 5b times 5b, yeah, you get the 25b squared, no big deal. But 25 or 5b times negative 4, that's negative 20b. And negative 4 times 5, that's another negative 20b. And negative 4 times negative 4 is positive 16. So these middle values don't end up becoming negative 4b. It's actually negative 40b. So this factored form did not work. That means it's not factorable, right? You can't even pull out a GCF from the original, which, by the way, you're supposed to try to do. From at the very beginning, try to pull out a GCF, but you can't even pull that out. So this whole thing is not factorable. We could just write the word prime because it's not factorable. So it's kind of like what we were doing yesterday, but yesterday we had a difference of two squares, right? Like we had x squared minus 9, or 25x squared minus 9. You could do the square root, and plug it into your answer format. One was plus, one was minus. This one's a little bit more challenging, okay? So the next section right here, it says factor if possible. If you can't factor it, write prime. On all of these, you're supposed to start by trying to do what? What are you supposed to start with? You're supposed to start pulling out the GCF. Correct. Pulling out the GCF. So what's in common in both of these terms? 3. If I pull out a 3, what's going to be left? So pulling out the 3, we'll have a p squared left and minus and a 49. Now, because I pulled out the GCF 3, I could just focus in on the inside of the parentheses now. I'm going to ignore the 3 for a little while. And in there, I really do have the difference of two squares that we learned yesterday. So the difference of two squares becomes p and p, because the square root of p squared is p, and the square root of 49 is 7. And of course, one has to be plus, one has to be minus in order for the middle term to cancel out, or in order for you to get negative 49, right? Now let's not forget about the 3 that's out in front, the GCF we pulled out to start with. So ladies and gentlemen, this is the completely factored form of number 7. Let's jump to number 12. So on number 12, what should we do first? GCF, that's right. What is the GCF in this thing? So the GCF is 2. If you pull out a 2, what's going to be left? A 15k squared plus 19k plus 6. So we pulled out the 2. Now we could kind of ignore the 2 and see what else we could do. Now, unfortunately, this is not a perfect square term. That's not a perfect square term, so there is no shortcut. I need to deal with this. I need to actually work through that long process of step 1 multiplying a times c. And step 1 multiplying a times c, what is 15 times 6? So a times c is 90. 15 times 6 is 90. Step 2 is to think of the multiples of 90 that combine together to give you 19. You might want to make a list. If you think it through, 10 times 9 is the correct pair of numbers that give you 90, that if you combine give you 19. Step 3 is to rewrite your entire quadratic trinomial as 4 terms so you could factor by grouping. So you're going to have 5k squared, it's 15k squared, and the 19k I replaced it with 10 and 9. So 19k really is 10k plus 9k, that's a total of 19k's. Notice that I left some space between it. So we are going to be factoring by grouping. What could I pull out of the first group? 5k. If I pull out a 5k from there, what's going to be left? 3k plus 2 is correct. Okay, in the second group, what could I pull out of the second group over here? That would be a positive 3 that you could pull out of there. What would be left? Again, a 3k plus 2. And then finally, let me put a line right here. Finally, we're going to pull out what's in common in the first group and the second group, which is the binomial 3k plus 2. I want to write it down here. I want to write it as 3k plus 2. And what would be left on the inside if I pull out the 3k from here, the 5k would be left. If I pull it out from here, the plus 3 would be left. So the 5k comes down and the plus 3 comes down. And ladies and gentlemen, that's your factored form. However, let's not forget about the original GCF 2. Let's slap that guy right in the front. So there's a 2 right in front of there. Ladies and gentlemen, this is the completely factored form for number 12. That one was long. That's probably one of the hardest types of questions you'll see on the test on Thursday, on the chapter test. That's the hardest type of question. If we take a look at... If we take a look at number 16, we could pull out a GCF. What's a GCF? 7. What's left when I pull out a 7? U. Just a U? U squared minus 4m squared. Now right here we should notice that if we ignore the 7, the GCF, we ignore the 7 and put it to the side, and just focus in on the inside of the parentheses. You have a perfect square term here, perfect square term there. It's a difference of 2 squares. Those are the easiest because you could automatically jump to this factored format where you take the square root of u squared and get what? U, and the square root of 4m squared. The square root of 4 is 2, the square root of m squared is m, so 2m and u and 2m. And let's not forget that one has to be a plus, one has to be a minus in order for you to get the middle term to cancel out. And let's also not forget the outside 7 that we had out there. This is the final factored form right there. Let's see if I can find one that actually has what we're doing. Check out number 15. This is what we actually learned today. You do have a perfect square term in the front, perfect square term in the back. Maybe we're going to be able to jump to our factored form using the shortcut of taking the square roots. So what would be inside my factored form answer? Square root of 9n squared? 3n. 3n. How about the square root of 25? 5 and 5. Now, ladies and gentlemen, in order for you to get negative 25, this positive 5, this negative 5, or negative and positive. But the problem there is, if you did put a minus and a plus, or a plus and a minus, when you distribute, your middle terms will end up canceling out. Yeah? And the problem is, there is a middle term. It doesn't cancel out. So even though we identified perfect square terms in front and back, and even though we tried this shortcut, it does not work, because that factored form would give us 9n squared minus 25. It doesn't have the minus 30 in there. So this whole thing didn't work. This is simply not factorable. So this one's prime. Number 9, first pull out the GCF. And if you pull out that GCF, you're going to have this left over on the inside. And then you should recognize that the inside does have a perfect square term in the front, perfect square term in the back, so you could use the shortcut. The square root of 25q squared is 5q, and the square root of 9 is 3. So 5q and 3. I shouldn't have put plus. I need to think of the signs. In order to get the positive 9 and the middle term negative, both of them have to be a minus. Check it and you'll see that it is correct, but I ran out of time on this video.